Hey guys, it's Sashi back again with video number 11 for problem number 11 from a Physics C mechanics multiple choice test. Let's jump right in. So the question posed here is a 2 kilogram object is released from rest from a height of 3 meters above Earth's surface. How much kinetic energy does the object have when it reaches a height of 1 meter? So we know we're dealing with energy equations. We have gravitational potential energy. It's released from rest from a height of 3 meters above Earth's surface. That tells us we're talking about gravitational potential energy. And then it explicitly says it's asking how much kinetic energy is it going to have when it has reached a height of 1. So let's just write this out. So energy initial is equal to energy final in a closed system such as this one. So our energy initial is all gravitational potential energy. So we're going to go mass times gravity times height initial, and then how much kinetic. The second sentence is talking about the final conditions in this problem. So we're going to have kinetic energy 1/2 mv squared. And then when it is at a height of 1 meter. So there's going to be leftover gravitational potential energy when it's at 1 meter. At the start, it's only gravitational potential energy. At a height of 1 meter, there's kinetic energy and gravitational potential energy. Mass times gravity times height final. So let's start to plug stuff in. First of all, we can cross out these m's. They cancel out. And G is about 9.81 meters per second squared. But let's round this for the sake of the problem to 10. That's just going to make calculations a little bit easier. That's what they expect you on the AP test as well. So here's it zoomed in so you can see a little bit better what I've been doing so far. So 10. What is our initial height? 3 meters. 10 times 3 is equal to 1/2 times our velocity squared. This is still the kinetic energy part of our equation. And then plus, again, we have G and height final. Height final is 1. So let's multiply these out. Let's see. Alright, 10 times 3, 30 is equal to 1/2 v squared. Again, this is our kinetic energy. We're going to want to keep track of this term. Plus 10. Simplify, isolate kinetic energy by subtracting 10. We have 20 is equal to 1/2 v squared. So let's multiply by 2. And v squared is our potential energy. So our potential energy here is going to be 40 when we have reached a height of 1 meter. We did this by using our energy equations, and energy initial is equal to energy final. We started off with just gravitational potential energy, and we end with gravitational potential energy as well as kinetic energy. We can cross out the m's, we can simplify, we can multiply here, and we're trying to isolate the kinetic energy part of the equation. So we solve for V2, and this luckily matches right up with our answer here. So I want to take this time to explore another side of energy equations. There's different types of energy we can represent here. So this is gravitational potential. This is kinetic energy. There's also spring potential energy, which, let's write this down here. This isn't in the problem, but it's an additional important part of energy equations that we're going to need a little bit later on the test. So spring potential energy is 1/2 kx squared. So this can be written as U means potential energy. So U spring is 1/2 kx squared. Sometimes you see this written as delta x to show the change in distance. And then K is the spring constant. That's going to be on the reference sheet for the test, so you don't have to memorize that. But that's another important potential energy. However, this equation doesn't have springs. You're just going to need kinetic energy and gravitational potential energy to solve this one. Pretty straightforward energy equation. Let me know if you have any questions. Drop some comments below. Thanks for watching.